So now, let us learn some more about second order derivative. And say that you have a function given to you, y equal to cos of log of 3 times x. So this given function, we see that on the right hand side, the only independent variable that can change is the variable x. So what we do is, when we wanted to find the derivative of this function, we have to differentiate with respect to x. So now we differentiate both sides with respect to x to find out the first order derivative. So you'll be having dy by dx equal to derivative of cos of log of 3 times x with respect to x. And this given function, it is a composite function. And we know that whenever the given function is a composite function, to find the derivative, we have to always apply the chain rule. Now, when you apply the chain rule, you will have to write down like this: derivative of cos of log of 3 times x with respect to log of 3 times x times derivative of log of 3 times x with respect to x. So that is the first step, that you applied the chain rule. Now the first derivative will become minus sine of log of 3 times x. So the second derivative, again, you see that function log of 3 times of x is again a composite function. So there is no straight formula to find out the derivative whenever the given function is in the composite form or a composite function. So what we do here is, again, we apply the chain rule. And when we apply the chain rule, it will look like this: derivative of log of 3 times x with respect to 3 times x into derivative of 3 times x with respect to x. So the derivative of log of 3 times x with respect to 3 times x will be just 1 upon 3 times x. Now the last derivative, you see there you have 3 times x, and 3 is a constant, so we can take it out from the given function, and now you have derivative of x with respect to x, and that is simply equal to 1. So now your first order derivative will be minus 1 upon x sine of log of 3 times x. So this is the first order derivative. And now let us find out the second order derivative after you have got the first order derivative. And we start like this. So we have got the derivative of the given function, the first order derivative. It is minus 1 upon x times sine of log of 3 times x. Now again here, we see that on the right hand side, the only variable that can change, it is x. Though there are two x's here, but still it is the same x, and the only variable that can change independently. So what we do is, to find the second order derivative, we differentiate again both sides with respect to x, because x is the only independent variable that can change. Now differentiating again both sides with respect to x, you'll be having d dx of dy by dx equal to d dx of minus 1 upon x sine of log of 3 times x. Now, here what we do is we will take minus 1 upon x as the first function and sine of log of 3 times x as the second function, and we apply the product rule first of all. So first we apply the product rule. Now when you apply the product rule, what we do is we leave aside the first function, differentiate the second function, plus leave aside the second function and find out the derivative of the first function, which is minus 1 upon x. Now, after applying the product rule, so you have to start finding out the derivative of those functions which you are required to find out. So the first one will be derivative of sine of log of 3 times x with respect to x. And this given function is again a composite function, and it is similar to the given function. Here you have sine log of 3 times x, and in the given function you have cos of log of 3 times x. So they are similar, and you can try on your own. So you can apply the chain rule again, and when you apply the chain rule, you will be getting cos of log of 3 times x into 1 upon 3 times x times 3. Now, further on the extreme right, you have derivative of minus 1 upon x with respect to x. So what we do is we take out that minus sign, and you will be left with 1 upon x. So here you will have to apply the quotient rule. You will have to apply the quotient rule, and after applying the quotient rule, you'll be getting 0 minus 1. So that is the last step, and now you just need to simplify. And when you simplify, you'll be getting just like that in the last line shown on the screen. So this is how we do to find out the second order derivative of functions which are composite functions. So how do you know that a given function is a composite function? The simplest answer, we can say that the function is a composite function when the function given to you is not in the standard form. So instead of cos of x, you have cos of 2 times x, then that is definitely a composite function because it is not in the standard form.